Starting from this simple project, we want now to dim a LED, the light emitted by a LED, based on the voltage read on the analog input. And we also want to set the position of a servo motor based on the voltage read on the analog input. And so we need to add to this project a LED and a servo motor. So we can start from this project. And first of all, if we want to share this project with other people, you have to go here in Properties and select Public. We have to save the changes. And next, if I click on this project, here I have a link, copy link, a public link that all people I can share with all people interested, for instance, in this project. So I can send this project to all people interested in it. After having saved it, I can close. And I can also duplicate it, copy and paste it. So if I click on duplicate it, I have another, the same project called copy. I change name, example 2. And now I can work to this project that starts from the previous one, but I can add all the components I need. For instance, a LED, we put it in a useful position. And for instance, this one, the LED is characterized by a cathode who can be, for instance, connected to ground, and by an anode, we should be connected to a digital pin of the board by means of a resistor. The resistor value should be selected in order to have a 10 milliamps current, for instance. So since on the LED there is a voltage drop of about 2 volt, we can have a 270 ohm resistor to have about 10 milliamps of current on the LED. So the value of the resistor is the one who selects the LED current. LED current is suggested not to be above 20 milliamps. 10 milliamps is the best value to guarantee a long duration of the LED. So we put it here, and we can connect to digital pin 9. So when digital pin 9 is 1, the LED is on with current about approximately 10 milliamps. When digital pin 9 is 0, the LED is off. Digital pin 9 is a special pin, I zoom it, because it has this tilde. That means that it is a PWM pin, and we are interested in connecting the LED to a PWM pin because PWM pin can provide on output a square wave with a programmable duty cycle. In fact, if we want to regulate the light emitted from the LED, so LED dimming, based on the voltage value read, we can regulate the duty cycle of this square wave based on the value read on the potentiometer. So, to see the visibly these characteristics, we can take an oscilloscope. This is a basic oscilloscope, and the oscilloscope has 2 terminals, positive, negative. Negative has to be put to ground, and positive can be connected to the PWM waveform to test it and to verify what we expect. So, for instance, we can put it here. Okay, so we can observe on the oscilloscope the waveform. Finally, we want to add a servo motor. We have two different micro servo motors. They are the same. For servo motors, we have ground, the power supply, and the signal. So there is an important thing now to have, because we can connect the servo motor power supply to the 5 volt of the Arduino board, but this is not suggested because servo motors, especially when they start, absorb a lot of current, and the Arduino board may become unstable. So it is better to provide the power supply for the servo motor from an external source. So we have an external power supply. We can put it at 5 volt. We have to be sure that the ground of the external power supply is connected to the ground of the Arduino board to be referred to the same potential. Next, we can supply our servo motor with the external 5 volt power supply. So we have no problem with the current required by the servo motor. The ground also can be connected directly to the external ground, that is, however, the same as the board ground. But it is better to have a lower path resistance between the external power supply. Finally, this is another digital pin. It is not important a PWM pin, so we can connect it also to pin 8, for instance. And we select the color, for instance, blue. Okay, so we have all the connections we need. First of all, we want to regulate the duty cycle of the PWM form on pin 9 based on the voltage read. So what should we do? We can say that the variable duty cycle, we call it duty, is equal to analog data divided by 4. Why we divide it by 4? Because analog data changes from 0 to 1023, while the duty cycle changes from 0 to 255. So the duty cycle is an 8-bit number, while analog data is an 8-bit number. So to convert an 8-bit data to a 10-bit data to an 8-bit data, it is sufficient to divide by 4. This division is done in a different way because you know that to divide a digital number by 4 is equal to do a shift on the right by 2 positions. So we can just do something like that. This instruction is shift to the right of 2 positions. So duty is the same number of analog data without the 2 least significant bits. It is the same operation as this one. Okay. And this duty is put on the LED with analog write We select the pin. This should be a pin with a PWM. For instance, for the Uno board, we can use pin number 3, 5, 6 with the tilde, pin 9, 10, 11. So pin 9 and the duty cycle we have derived from the reading of the potentiometer. So we can print also the duty cycle. So here we have print the voltage. Now we print the duty cycle on the same line. So new line just at the end. So we print the duty in this way. And here the measurement unit is a percentage. No, duty is the number from 0 to 25. If we want the percentage, we have to divide it by 225 times 100. Okay, because duty changes from 0 to 255, and we want to print the percentage of duty. So it is 100 times duty divided by 255. Let's say one of these numbers is real to have an exact percentage. Okay, let's see how it happens. So what we read, there is a space we have to add here because we read the voltage and the duty exactly attached to the voltage. So the space is done adding some spaces here. Okay. Now we can restart the simulation and read. We have we read 613. We have 3 volt on HU input, analog input, and we have a 60% duty cycle. So we have 60% brightness. We can add it, for instance. We read now 859, corresponds to 40 volt, and we have 83% duty cycle. This LED will be brighter. This is maximum brightness. You see, we read 1023, corresponds to 5 volt, and it corresponds to 100 duty cycle. And we see here lower light because we now have just 600% duty cycle, so the LED is less bright. And if we want to turn it off, it is sufficient to have 0 volt with the trimmer, so we can regulate the duty cycle with the potentiometer of the PWM, so we regulate the brightness of the light with the potentiometer. This is a technique called PWM. Here we can see the waveforms, but in place of 1 second. Okay, we can see also on the oscilloscope. So we have a low duty cycle, and you see the period here is about 10-20 milliseconds period. It is a fixed period. But we can change the duty cycle, and you see that the T on versus the T off is increasing. We can go with a very high duty cycle by regulating it with the potentiometer. Okay, so if we have read a voltage close to 5, the duty cycle is almost 110%, so the voltage is always 5. Instead, if we decrease the duty cycle, you see that we have a lower T on, and here we are about at 50% duty cycle. It is 47.84%. If we decrease, you see there is a very low duty cycle and a very low brightness of the LED. This is LED dimming with PWM technique.